Hi everybody. Hope you're having a wonderful day so far. Today we're not necessarily going to be learning anything new. What we're going to be doing is we're going to be going back over all the different special quadrilaterals that we've talked about. Kind of all throwing them into one bag and being able to work with each one and their properties as they come up. We've talked about 6 special types of quadrilaterals. Okay, here they are. We started off with parallelograms. We spent a couple days talking about that. After that, we threw in rhombuses, rectangles, and squares, and the reasons that we did those after parallelograms is they're all special types of parallelograms. So everything we know is true about a parallelogram is true about rhombuses, rectangles, and squares. We added in trapezoids and kites just recently. There we go. Trapezoids that also include isosceles trapezoids. So we have these 6 or maybe 7 if you want to count isosceles trapezoid as something different, types of quadrilaterals. And there's a lot going on here. There's different definitions for each. There's lots of properties. So that's what we're going to be looking at today. So let's open up our notes here. Our first couple questions are, what types of quadrilaterals have the following trait? Okay, so I'm not looking to classify it here. I'm looking for a list if this is true in any quadrilateral. Okay, so opposite sides are congruent. Well, considering our list here, opposite sides are congruent, we should probably ask if that's true with parallelograms first. So are opposite sides in a parallelogram congruent? The answer to that is yes. That's one of the first things that we learned about parallelograms is opposite sides are congruent. So, I'll just type here instead of writing. This is true for parallelograms. Okay? Now, if it's true for parallelograms, what does that tell us? It's also true for rhombuses, rectangles, and squares. Okay. Now rhombuses, all 4 sides are congruent, but the opposite sides are still congruent, aren't they? Okay. Rectangles, squares, opposite sides are certainly congruent. Okay. Now let's check here. In a trapezoid, are opposite sides congruent? Okay. So picture our trapezoid. Are opposite sides congruent? Well, are the bases congruent? Are parallel sides? No, they can't be congruent, otherwise it wouldn't be a trapezoid. We'd be switching back into a parallelogram. Now, in an isosceles trapezoid, the legs, those opposite sides are congruent, but when we say opposite sides are congruent, we're talking about all pairs of opposite sides. This is not true for a trapezoid. Is it true for a kite? Certainly not. We know one thing that makes it a kite is that the opposite sides aren't congruent, that it's the consecutive sides. So we've got parallelograms, rhombuses, rectangles, and squares. All right, how about opposite angles being congruent? Okay. Again, start with the parallelogram. Are opposite angles congruent in a parallelogram? Yes, they are. Okay. Now, if it's true for parallelograms, then it's true for, again, rhombuses, rectangles, and squares. Are opposite angles congruent in a trapezoid? Nope. Are opposite angles congruent in a kite? Now we have one pair of opposite angles congruent in a kite, but not both pairs. That would be our answer there. Okay, if you haven't noticed, I'm really trying to hammer it home to you guys that if it's true for a parallelogram, okay, it's true in rhombuses, rectangles, and squares. Next questions. Let's see here. Let's just start with these two. What's the most specific name for the quadrilateral? Consecutive angles are supplementary. What's the most specific name that we can give based on just that information that we have? If all we know is that consecutive angles are supplementary, what's the most specific name that we can give? Well, again, go back to our list here. Parallelograms. Are consecutive angles supplementary in parallelograms? Let's draw one. So are consecutive angles, is this angle supplementary with that one? Is this angle supplementary with that one? Yeah, that was, again, one of our first things that we learned about parallelograms is that consecutive angles are supplementary. So we know for sure it's a parallelogram. Now, the thing that students have a difficulty with on this one is, are consecutive angles supplementary in a rhombus? Yeah, they are, aren't they? Are consecutive angles supplementary in a rectangle? Yeah, they are. They're both right angles. Okay? They add to 180. How about in a square? Yes. Okay? So consecutive angles are supplementary in parallelograms, rhombuses, rectangles, squares. But is just knowing that enough to know that it's a rhombus? Does it tell us anything about the sides? No. Is just knowing that consecutive angles are supplementary enough to know it's a rectangle? Okay. Do we know that they have to be 90 degrees if this is the given information? Again, no. Well, if it can't be rhombus, it can't be a rectangle. That means it can't be a square. Okay. The most specific name that we can give, if that's all we know, is a parallelogram. Letter B. Exactly one pair of parallel sides. If we know we have exactly one pair of parallel sides, what's the most specific name that we can give it? Yeah, it's a trapezoid, isn't it? This is a trapezoid. Now, is there enough information to know it's an isosceles trapezoid? Does it tell us anything about the legs? Does it tell us anything about the base angles? No. So the most specific name that we can give is a trapezoid. Next two, okay, given diagrams here instead of just a sentence. What's the most specific name that we can give for this one? I see four congruent sides, which tells me for sure it's a, here you go, like a children's cartoon, blink, blink, wait, it's a rhombus. Okay. Is there enough to know it's a square? Do we know anything about the angles? No, we don't. Most specific name for this one? Rhombus. Good. Letter D. What's our most specific name here? Well, those angles are the same. Could we find this missing angle? Let's see here, 360 minus 102 minus 102 minus 78. Let's see here, that's 78, isn't it? So we've got congruent angles. These angles are congruent. Those angles are congruent. Okay, you're probably thinking isosceles trapezoid. Because if the base angles are congruent, then it's isosceles trapezoid. But let's hold on just 1 second here. I want to look back at our notes about what we learned about trapezoids and base angles. Okay. Look at theorem 8.15 here. What does this say? If one pair of base angles in a trapezoid are congruent, then the trapezoid is isosceles. Okay. If you read this carefully, we have to first know it's a what with congruent base angles. We first have to know it's a trapezoid. And if we know it's a trapezoid and the base angles are congruent, then it's an isosceles trapezoid. Okay. So we've got to ask ourselves first, do we know that this is a trapezoid? Okay. Do we know this is a trapezoid? Well, we need to look to see if there's exactly one pair of parallel sides. Take a look at this. That's 102 degrees. That's 78. Those are supplementary, aren't they? Okay. Those two add to 180 degrees. Okay. What's that tell us? If consecutive angles are supplementary, then the lines are parallel. Those two are parallel, aren't they? Okay. Are these two sides parallel? No, certainly not. 102 and 102 are not supplementary. Okay, those are not parallel. So it is a trapezoid. Okay, so now that we know it's a trapezoid and the base angles are congruent, we can say it's an isosceles trapezoid. All right, continue on. Let's see here, where were we? All right, I notice these sides are congruent. I notice those sides are congruent. Okay, those are consecutive sides congruent. We have two pairs of consecutive sides congruent. Opposite sides are not congruent. Okay, this must be a kite. Good. To left. All right, take a look at this one. 90, 90, 90. What do the angles in a quadrilateral add to? 360. That makes this one must be 90. So we have 4 right angles. That guarantees that we have a rectangle. Do we know it's more than a rectangle? Is it a square? Do we know all 4 sides are congruent? Definitely not. This one we have a rectangle. Take a look at letter G. Those are congruent. Those are congruent. So the diagonals bisect each other. If you recall, if the diagonals bisect each other, then it's a parallelogram. Do we know it's more than a parallelogram? Well, notice not only do the diagonals bisect each other, okay, we notice that they are perpendicular. Take a look at the 4 triangles that we have there. Okay, they're all congruent by side angle side, aren't they? That gives each of these sides the same length, which means for sure it's a rhombus. Okay, now let's take it one step further. Okay, is it a square? Well, what kind of triangles are these? Okay, they're isosceles right triangles, which makes them all 45, 45, 90s. Okay, so if we have that all of around the circle, we've got right angles in every vertex. Okay, this is a square. Good. Okay. I think you guys are doing a good job picking up, breaking them down in the triangles and looking for congruent triangles. That's important. So that's going to wrap up our notes for today. Thanks for tuning in. We're certainly not done with what we've been talking about. We still need to work more together. But thanks for tuning in, Okay, please follow the directions for what you need to do next.